So this week we talk about weather analysis, which is basically observing the weather and forecasting. If you don't know what the current weather is, you can't make a forecast of what the weather will be. So one of the key things we're going to talk about is how do we, the scientific process involved in making a weather forecast from learning what we have observed. The World Meteorological Organization is headquartered over in Switzerland. It provides a coordination between, as it says here, 188 nations. We all share weather. It's one of the few things in the world that everybody will share. But all the geosynchronous satellites up there, the polar orbiting satellites, upper air soundings, surface observation, I can go anywhere in the world and get a surface observation as long as they're being made. Just because it's needed, but if you're going to make a forecast for any country, you need to know the observations around you. So everybody shares observations. National Center for Environmental Prediction is responsible in a large way for the forecast in the U.S., except the U.S. has 122 local offices that actually write the local forecast. So this is the observing network. Look at it. If you looked at it and think about it, over the land, there's a lot of observations. We have satellite, we have radar, we have automated weather systems, we have surface AWOS, AWOS, upper air systems. We even have a lot of cooperative networks. Over the ocean, you might have a ship, you might have a buoy, and there are aircraft too over the ocean sometimes that take observations as they're flying, and satellite. Another thing with aircraft is they do observations when they're landing and taking off. So some airports, you get a lot of weather every hour, literally a sounding, looking up and down through the atmosphere every hour. Here's just an example of a weather station. And here is the surface, a buoy. There are several of those all around the United States, offshore, in different locations, trying to give meteorologists an idea of what the weather is out there. Here's a cooperative network. Cooperative network is basically almost like a climate network in a way, because it does observations. You get them about once a month, and they're there for your edification to learn, see what happened at that location throughout the entire month. You really don't get them in real time. You can call the people and ask for an observation, but if you're a meteorologist working for the federal government, you don't get them in real time. So sometimes that leaves some holes. And you can notice, there's a lot of these stations around the country. Radiosondes are just a balloon going up with a little transceiver on the bottom of it, GPS tracking it for the winds, and it gets the pressures and temperatures and stuff as it goes up, and moisture. So all those SQTs and Stuvie diagrams you saw, most of them were generated by this instrument going up. And you can see the network here. Lots of holes in that network. Notice there is no station in West Virginia. So there are holes in this network, but it's about as good as it's going to get right now. All this data is processed and displayed for meteorologists with AWIPS. AWIPS receives every observation. It receives every numerical model. It receives every kind of a forecast we can think of almost. And we try to put them together on screens. You can notice you can have 4 screens at one time and 4 along the sides. So you can actually get 8 screens you're looking at. All of it to get the most information that you can use to make a forecast with. Various forecasts from numerical weather prediction generally range anywhere from 12 hours out to 7 days, and some climate forecasts even go out to 90 to 100 to 360 days. There are various types of numerical models. They mention the GFS, Global Forecast System. This looks at the entire globe, a little bit broader scale, but it does pick up. It's getting higher and higher, and they just upgraded it again where it says it was first 8 days are now run at 28 kilometers. That is now at 15 kilometers. And the second, I think, are we at 35 kilometers now. And they hope to even get it tighter than that. NAM is a mesoscale model. There was a difference between global forecast systems models that look at the whole world, basically, and the NAM, which looks just at the United States, parts of the Atlantic and Pacific Oceans. Also, the NAM is a convective allowing model. Global forecast system approximates convection, but the NAM and the high resolution rapid refresh models allow convection. That's a big difference. It allows for more detail looking at the smaller scale in weather, which in the first 18 to 12 hours we might be very interested in. And then there's something called ensembles. Basically, ensembles, you run about 20 to 30, sometimes 100 and some different models, all with different initial conditions or different ways of looking at the physics in the model to try to encompass what is actually happening in the weather. Somewhere in that group of forecasts, hopefully, is reality. But the idea is to look at where the median of the models are, where most of them are occurring, where the averages are, just to see, and to see the spread of the models to just know how bad they can be. And you can see here different errors. Numerical models and new observation systems have all helped tremendously. How in your tropical forecasting errors as far as positioning goes. Intensity, we still got some issues. Parts of NCEPT are divided up. There's an expert center in Kansas City that deals with aviation weather. And that is what their expertise is, aviation. If you're a pilot or flying, you want to know where get the best forecast and stuff. A lot of that expertise is centered right there in Kansas City. Storm Prediction Center in Norman, Oklahoma is responsible for issuing watches for severe thunderstorms and identifying areas that might have severe thunderstorms. They also might monitor where very heavy rain or blizzard conditions might be occurring and give an outlook that they may occur. One other one is river forecast centers. River forecast centers basically are looking for rainfall. They're looking to see how much rainfall is going to occur, how much of that rainfall is going to run off, how much high the rivers are already, how wet the basins are. All of that goes into making a river forecast. And if you'll notice here, Wilmington, Ohio covers most of West Virginia. If you're on the eastern side of West Virginia, Mid-Atlantic RFC is what does it. Just south of that is Peachtree. There's also, NCEP has ocean prediction centers and space weather prediction, actually doing forecast for sunspots and radio signals. The first 48 hours, the skill is pretty good, really, and it declines rapidly after that and reaches not much better than if you flip the coin at about 10 days. So why is that? Because we can't observe the weather in detail, and we're approximating it as we go out. So both of those errors multiply with time. But between 1 to 5 days are a pretty good forecast now. I used to do verification all the time, and we considered a miss on verification if we were off by more than 10 degrees in one day for a max or a min. And if we were off by more than 5, we considered it not a good day. And probability-wise, if we were off by more than 20%, if we said it was going to be an 80% chance and it was actually only a 60% chance, we considered that a miss for that day. And reality is we were 95 to 99% skill level is what we generally forecast. You can expect, yes, we're going to miss some, and those are the ones that everybody remembers. And here is the idea that meteorologists will continue not to be replaced by computers. Back in the 80s, there was a lot of talk that the computers were just going to take over all the jobs from the meteorologists. It was all going to be computer generated. And they very quickly learned that that's not the case. Forecasters can take into account experience and look at things in the past, have some intuition, and wind up almost always beating the forecast models. Climate Prediction Center is long range. One of the things I wanted to mention with NCEP is all that information, all that expertise is fed to the 122 forecast offices who make the final forecast. When you're looking at watches for winter weather, when you're looking at things for temperatures daily or whatever, you're contacting your local forecast office. So while they incorporate the expertise from NCEP in these different areas, even flooding, rivers flooding and all, the expertise may be out at the ocean, at the river forecast centers, but the final product is issued by the local forecast office. Private sector has gotten into forecasting now. And all this is communicated, watches, warnings, advisories. There's all kinds of different watches and warnings. The National Weather Service has been trying to simplify those through the years, but we still have lots out there. As long as you understand that a watch means conditions may occur, a warning means they either are occurring or they're highly likely to occur. We also talked about Weather Ready Nation here. And basically all that is we ask communities to work together to build communications within the communities, between authorities, between the Weather Service, between emergency managers, to strengthen the partnership there so that when the meteorologist issues information, the community knows how to take the best advantage of that information. So with that, I just wanted to show you quickly a couple things. This is another way of looking at weather is statistics. We can look and you look back at maybe 180 days or whatever, a forecast, and see what actually occurred, and then write statistical programs that are like this. And this, for example, is Beckley. Today's low would be 26, tomorrow's high 41, 27. And this is actually an ensemble of forecasts. It looks at all different kinds of forecasts. And you can see the spread's not real big, 1 degree, 2 degrees there, 2 degrees here. So there's really not a lot of error expected in this kind of forecast. We also try to work together to get good observations. And here is a typical map of observations, not the highest resolution we get, which really isn't great. If you look at it up over New England, can you tell if it's heavy snow here or heavy snow here? What's going on here? I would argue that there's a low pressure system just south of Cape Cod right now. Look at the temperature here, 62 degrees. Temperature in Boston, 43 degrees. Pretty strong temperature gradient and all. So here is just an example of global ensemble with the GFS forecast system, forecasting where this low is going to move to today. Here it has it. Very intense low up over New England, moving out to sea. There's another one coming in towards Alaska and the West Coast. You can look way out in the future and see what these are doing. If you wanted to take a more different approach, looking at actual radar with the HRRR model, very high resolution model, looks at about 1 kilometer grid spacing, sometimes 1/2 kilometer, and you can see it actually prints out rain snow lines here, shows you convection offshore, and this is a simulated radar map. So you can actually argue you're looking at how intense the precipitation will be and where the rain snow line is according to the model. Again, this is a model forecast. Here is an ensemble forecast. Here is a forecast for where the low is on this ensemble. If you look at a separate ensemble, same exact time, but notice the low is much further northeast and weaker. So if we were making a forecast for Maine, we'd have to be figuring out which way was the best way to go. So this is the current observation forecast and produced by the Weather Prediction Center in College Park, Maryland, part of NCEP. This is their forecast. You can actually see this day 2, they bring a little low coming out from the Gulf and across to the south, the United States, and then out to sea. One of the interesting things with this, you can actually say we were interested in winter weather, which is what's going on right now. We could look at snowfalls, and this is a greater than 4 inches. And you can see high probabilities over Maine and all today. And if you wanted to really get down to some things with them, one of the interesting things is they actually look at surface low tracks. And with that, they look at where the different models forecasted. You can see almost all the models are very close here, a little bit spread out. Then they're starting to get a little further apart, a little different intensities the longer out. But this is really a very well forecast system here. So this is just an example of the forecast you're going to see, how the forecasts are made, and the final products are basically maps that your local weather service office produces at a 2.5 kilometer grid. And out of that map, you can get your local forecast over the next 5 to 7 days, literally every hour. So hope you got something out of this little bit. Let me know if you have any questions.